All right, so we're looking at 5.6, and 5.6 is going to be similar eventually to what we've been doing in chapter 5, but it also brings in some stuff that we did earlier in the year. We are dealing with inequalities today, and we are going to be graphing inequalities. Now, we've graphed inequalities in terms of, we graphed this where we had the number line, and we graphed it like that. It's not that sort of graph. Okay, we are now graphing linear inequalities. So linear inequalities are going to look something like 3x plus 2y is greater than 7. Okay, this is a linear inequality where we have an x and a y in there, but instead of an equal sign, we've got an inequality sign. We're going to be graphing this today. Okay, we're going to be graphing this. Before we do that, we're going to see problems where, all right, here's our linear inequality, and I want to know, is this a solution? So all we would have to do is plug in those numbers for x and y and see if the statement holds true. So I want you to go ahead and do that. Plug in a 4 and a 2. Let's see if that statement holds true here. And that's either going to be in your head, that's going to be writing it down, however you need to is fine. All right, so we plug that in. Let's see, we plug that 4 in for x, that 2 in for y. If I'm going to write it out, I can write it out. That's going to give me 12 plus 4. That's 16 is greater than 7. So as long as the statement is true, then our answer is yes. It's a yes or no question. Right? So our answer would be yes, this is a solution. So they could put in any ordered pair here and say, is this a solution or not? Plug those numbers in. Right, for x and y, just make sure your first value is going in for x, your second one's going in for y. Check to make sure, is it a true statement or not? Does it work or not? And your answer is yes or no. Okay, pretty straightforward there. Just be careful on the sign, right? Let's say that we plug in some numbers here. Let's say we have 1, 2 is our ordered pair. If we plug in 1, 2, 3 times 1 is 3, 2 times 2 is 4. I've got 7 and 7. Is this going to be a solution or not? No, it's not going to be a solution. Right? I saw some heads shaking. No. 7 is not greater than 7. Right? It's not greater than 7. So you got to pay attention to the sign because that's going to make the difference in this sort of problem when you have a 7 and a 7. Here, it's not a solution. If instead we had or equal to, now it is a solution, right? So we got to pay attention to that. Okay. Good. Any questions on that first type of question? Or we're just plugging those numbers in, yes or no? Okay. Again, if you have questions, feel free to unmute yourself and ask or type it in the chat. That works as well. All right. So we are going to get into graphing here. And when we graph, we're going to graph using y equals mx plus b. And we've been doing this for chapters now. We've been doing this for a long time, graphing y equals mx plus b. We got to make sure that we're okay on it. But we are using that, and then we're going to take that one step further because it's an inequality now rather than an equal sign. Well, the first thing that I want you to do, let's do this. I want you to graph using an equal sign just as normal. I would like you to graph this. I would like you to graph that equation. Okay, y equals mx plus b. Put it on a coordinate plane. Go ahead and graph it. Remember, if we're going to graph, we've got our intercept at 3. So our intercept's at 3. And then we've got a slope of 2. That's up 2 over 1. Up 2 over 1, I've got another point, which is great. We can connect those. For today, you know, if you remember, when we were solving by graphing, we had to extend that graph, so we kept using the slope a little bit more. Let's do that. I want your graph today to span the whole coordinate plane, okay? So instead of just going up 2 over 1 and stopping, I'm going to go the other way as well, just so I can get a nice long graph here, nice long line. I don't want short lines today. I want a nice long line for what we're talking about. All right, so there's our graph. Hopefully we're okay on that. Some of us I'm a little unsure of because of the quiz that we just took. Some of us didn't graph quite correctly. So make sure we can do y equals mx plus b. So now we're going to change things. So this is with an equal sign. Now we're going to graph y is, let's say, less than or equal to 2x plus 3. Y is less than or equal to 2x plus 3. The graph's going to stay the same, okay? That is not going to change. But we need some way to represent that there are a bunch of answers here, right? There are a lot of different points that are going to be answers here. What I'm going to do is I'm going to list out a few points, and I want you to determine, are they solutions or not? Just like we talked about first thing, right? So I'm going to plug in some point, or I'm going to give you some points. I want you to tell me, are they solutions? Are they not solutions? Okay, so I've got 4 points there. I want you to determine yes or no for each one of those. Is it a solution or not? And once you have your answers, your yes or no for each one, then you can type them in the chat. Let's see if we agree. Let's use that chat feature to our advantage here. Looks like we got some answers coming in here. They look all the same. Yes, no, yes, yes, which is great. That is what we have here. We've got yes, no, yes, yes. So what I want to look at is where on the graph are these located? Okay, so if 0, 0 is yes, I'm going to put a dot at 0, 0. Okay, that is a solution. Negative 2, 3 is not a solution. Negative 2, 3 is not a solution. 4, 1 is. That's 4, 1 is a solution. And 1, 5 is a solution. Well, that one's on the line. That is a solution. Okay, so I've got a couple solutions over here. I've got this is not a solution. I will tell you that any point over here I know that all of these are going to be solutions. All of them. This point's going to be a solution. You can try them, but all of these points over here are going to be solutions to this. Okay. All right, a couple people just joined. All of these are going to be solutions. Doesn't matter what point you pick over here, it's going to be a solution. Any point on this side of the line is not going to be a solution. Okay, so we can't go and put dots on every single solution. There's an infinite number of solutions here. Everything this way, going all the way out here, is still a solution. Right? Anything on this side of the line is going to be a solution. So what we're going to do is we're going to have some fun coloring today, even if it's just with a pencil. You get to shade the whole side of the graph. Okay, you get to shade that whole side. And I can't shade very well because I'll run out of markers by this afternoon. But you get to shade this entire side of the graph because that's telling us that anything on that side of the line is going to be a solution. Anything. Any point on that side of the line is going to be a solution. Anything on this side is not going to be a solution. It's not going to work. Okay? So if we look at this, okay, we got to figure out a way to be able to tell where we are going to shade and where we are not going to shade. Okay? We need to look at the symbol, and specifically the y and the symbol. If y is less than, y represents our points here. Okay, this is where our points are going to be located. If y is less than something, then our solutions are going to be under our line. Y is less than, it's under our line. You pick any point on the line and go down, that's where you're shading. So if y is less than, we're shading underneath the line. Okay, let's write that out. If y is less than or equal to, you're shading below the line. Okay, if y is less than or equal to, we are shading below the line. So then, because we are bright young minds and all of that, if y is greater than or equal to, we're going to shade above the line. So very important that you have this information in your notes. If it's y is less than something, we shade below. If y is greater than something, we shade above. Okay, very important. So the way that we're going to graph these, okay, you're going to get your original inequality into y equals mx plus b. And I say equals, we know that it's going to be an inequality. So it might be y is less than mx plus b, or y is greater than or equal to mx plus b. I'm going to keep saying it as y equals mx plus b just because we know what that means, right? We know that's what form we're talking about there. So get it into y equals mx plus b. You're going to graph that line just as you normally would. You're going to graph that line, and then you're going to figure out where are we going to shade it, okay? Levi brings up a good question. I will answer that towards the end. Okay, I will get to that. Just give me a couple minutes here. Okay. All right. So let's do another one here. Let's look at. Let's go. Markers are running out on me. Let's go. Y is greater than 1/2 x minus 1. Y is greater than 1/2 x minus 1 for this one. And let's try to graph it. So you can graph along with me. Okay, if you want to try going ahead, that's fine. So I'm going to graph my intercept at -1. I know my slope is 1/2. So from that intercept, I go up 1/2. I'm going to do it a couple times. I'm going to go the other way a couple times. Again, just to get that long line. Okay, I want to span the whole thing, so I know I'm not just talking about a small part of the graph. Okay, so I would graph that. Y is greater than, and we said when Y is greater than, we're going to shade above. So then we would shade above that line. We would shade above that line. So that tells me that any point that's shaded right now, any point that's above this line is going to be a solution. We can check and make sure. We can take any point that's in this shaded region, plug it in and make sure that it works. That way we know for sure that we got the right answer or we shaded the right way. 0, 0 is shaded. 0, 0 is above. So if I plug in a 0 and a 0, I would end up with 0 is greater than -1. That's true. That tells me that I shaded the right way. Okay? So all of these are solutions. That's why we have to shade and not put dots, because all of them are solutions. Everything up there. Now, one thing that we got to be careful of here. Okay, I want you to look at the point 2, 0. 2, 0 here. If I plug in 2, 0, is 2, 0 going to be a solution? If I plug in a 2 and a 0. Somebody type something, say something. Okay, I see some yeses, see some nos. Let's plug in a 2 and a 0. If I plug in a 2 here, that's 1/2 times 2 minus 1. That's 0 is greater than, that's 1 minus 1 is 0. Is 0 greater than 0? No, 0 is not greater than 0. So this is not a solution. So here's the problem, right? Last time, the last graph that we had, the line was a solution. If it was on the line, it was a solution. This time, when it's on the line, it's not a solution. We need to change the way our graph looks then. Right? Remember when we were graphing those linear or those number line inequalities, we either had a solid line or a solid dot or an open circle. Right? We had two different ways to look at it. We're going to do the same thing here. Okay? When we have a greater than, so it's not or equal to. If it's not or equal to, we need to change the way our line looks. And so what we're going to do is we're going to make it a dashed line. We're going to make it a dashed line if that line is not a solution. So with this dashed line, that means any point that's on that line is not a solution. That's the equivalent of our open circle, right? That's telling us, yes, the point's there. That's where the line is, but that line is not a solution here. Okay, so very important that we have in our notes, if we have greater than or less than, it needs to be a dashed line. If we have greater than or equal to or less than or equal to, it's a solid line. Okay, very important that we have that in our notes as well. Dashed line versus solid line. All right, we are running out of time. Okay, so we're going to try it, and then we will talk tomorrow all about it. Let me address the vertical line thing real quick. Okay, and then we're going to be done. If you have a vertical line, your vertical line is going to be the equation x and a number, right? That's a vertical line. We talked about that, x and a number. So let's say it's x is less than 4. Well, if I'm going to graph that, I'm going to be at 4. X is 4. This is going to be a dashed line because that's what we just talked about. It's going to be a dashed line at 4. And then instead of shading above and below, if it's just your x, If it's less than, it's to the left. If it's greater than, it's to the right. This is the only situation where you're not thinking above or below the line, is when it's x and a number. So if it's x and a number, less than means left, greater than means right. All other times you have to think of above and below. You can't think of left and right. Okay, very important. So for here, I would shade to the left because x is less than that number. Okay. All right. Will you have this on the homework? Yeah, everything that I just talked about will be on the homework. Yeah. Yep. All right. So we're just about out of time. Any questions on this stuff before we break? All right. Give me 1 second.